Hey there, my dear students! How are you today? Are you feeling good and excited? Or just okay? No worries, because I am here, Teacher Marian, who will give you the most exciting discussion you can learn. You're probably sitting next to a flat surface, like a table. Try to put something on it. It can be a book or a notebook. If you will look at it in a scientific level, you may say that the object that you have put in a flat surface exerts pressure. How do you think did I say that? Can you explain? That notebook is acted by a force, and putting it in a table will tell us that its force is acted upon in the specific area of the flat surface. Now, force over area is what we call pressure. Did you get it right? But that doesn't end there, because that isn't the case of solid substances. What about liquids and gas? Take a look at this. That's the OceanGate submersible, which tragically imploded during its expedition to view the Titanic wreck in the North Atlantic Ocean. Unfortunately, the implosion is said to have been caused by too much pressure of the ocean. How and why do you think did it happen? Let's do this. I have here a plastic bottle. It has 4 different parts with 4 different holes. I will pull water in it until it is full. Observe how water flows out of the holes. For the first layer, water flows at an angle. For the second layer, water flows at a wider angle compared to the first one. And for the third layer, water flow is literally squirting out. Why are those different? The water inside the plastic bottle exerts pressure. They exert pressure on the base and on the walls of the container they are enclosed. The pressure on the base will be downwards, and on the walls of the container will be sidewards. And take note, water pressure inside the bottle increases with depth. That's the idea behind the different angles of water flow in the holes. Since the third layer is holding the weight of the first and second layer, clearly the pressure at the bottom will be the highest or the maximum. That is the reason why water flow in the third layer is literally squirting out. But other than depth or height of the fluid, there are still 2 other factors influencing fluid pressure. The second one is density of the fluid, and the third is the acceleration due to gravity. Density is the measure of how tightly a material is packed together. Density varies according to the kind of fluid. Water density is at 1,000 kg per cubic meter. Meanwhile, acceleration due to gravity is given with a constant value of 9.8 meter per square second. Now, given these 3 factors, depth or height of the fluid, density of the fluid, and the acceleration due to gravity, we can have the formula in getting fluid pressure. And using that formula, we can now know what exactly is the pressure that the OceanGate submersible experienced underneath the North Atlantic Ocean, causing it to implode. Fluid pressure is equals to density of the fluid multiplied by the acceleration due to gravity multiplied by the height or depth of the fluid. The density of the North Atlantic Ocean, where the expedition is given with a value of approximately 1,028 kg per cubic meter. Acceleration due to gravity has a constant value of 9.8 meter per square second, and the depth of the Titanic wreck is 4,000 meters. Multiplying these values will give us the value of fluid pressure, and the answer is 40,297,600 kilogram meter per square second, or pascals, which is the SI unit of pressure. That's almost 400 times of the pressure we experience on the surface, which is 101,325 Pascal. As the submersible went deep in the ocean, it experienced the force on its surface due to the water pressure. When that pressure became larger than the pressure the submersible can withstand, it resulted to an implosion. Well, there are still other underlying factors we can consider, but that's another story to tell. That's it for our discussion about fluid pressure.